Okay, so we'll carry on with this very important concept, distributed database management systems. While you are looking at parallel databases, right? What do you mean by a parallel database? We're talking about multiple disks and multiple processors. Back then, we are only focused on one particular site. So your entire system will be on one location, getting queries and processing it. But when you talk about distributed databases, it is like your database is at multiple sites. So we'll take a scenario here. What is a distributed database? Data resides in multiple locations. So let's take a scenario as I told you. Let's assume that we have built an e-commerce web application and we have become successful selling products online for customers across the globe. Say we are an US based company and we are selling products to all the customers across the globe. And for my application, I'm going to store the data of customers using a schema that is given here. So I have the ID, name, phone number, company of country for all my customers. I'm selling products throughout the globe, right? They're going to use my application and buy products. So that is the scenario here, and I'm just taking one particular schema, the customer schema. What is this customer schema? It's for storing the data of my customers when they register themselves on the site. So let's take, since I'm talking about across the globe, I've taken the map here. And since we are a US based company and I have my server running in US, so that's where all my data is. So customers from across the globe will access this. How they will access? So they will, it can be a client server architecture. So using their clients, they are going to access my server from across the globe. And when I take a look at my database, the customer database, so how customers have registered, you can take a look at ID, name, phone, country. So they are from different countries here. So like that, we can have millions of records in my data store. So this is one kind of an scenario. But what are the disadvantages of this scenario? Disadvantages or the bottlenecks here, you see customers not only from US, customers from UK, customers from India, and you have customers from Australia. So many different parts of the world trying to access the data. So there will be a shipping cost, right? You have to ship your data to the customers on the network, and you are just overloading your one single server that is managing all your customers across the globe. So you have lots of data pouring in. So what the solution for this is, maybe what I think of is, instead of having one server, I know most of my customers are from US, India, UK, and let's take three countries. So what I plan is, I just go and have three databases now, three database servers, one in US, one in UK, another one in India. So each database server will have its own database management system. It will have its own database administrator. So now customers in the US, when they are trying to register their data, where it will be routed is to the US server. So those who are there locally, if you are in the US and you are trying to register, so you will be routed to the US server. So that data gets in there. If you are in UK and you are trying to register immediately, so it's all available locally. So thereby your response time may increase, performance increases. So now when you again take a look at the data stored for the various customers at the various locations, for US customers, you have the data stored at the site here. For the UK customers, you have data stored at this particular site. And for Indian customers, you have data stored at the database server in India. So now data is actually fragmented across different database servers across the globe. What is the advantage? I get easily routed to a nearby server and then I get the information. But you have to understand one thing, though data, you call these things as fragments. But when you talk about my application, my application is still one e-commerce application, three database servers managing my one application, right? So my application is just one application. So what is this table, this table, this table here? Together it is nothing but the customer table. All the three tables you are seeing here on three different servers is nothing but one customer table. That's what we have seen earlier here. If you just go and take a look at this one particular table got distributed across three different databases, servers, but still what we understand is all these three tables are just one table. That is the customer table, and that's what we have to understand. And it's still one application. Suppose I want to find the total number of customers in US. What I have to do? I have to be running a query here. Just do a count star on this table. I'll be able to get the customers. So I'll also be able to achieve some parallelism here because of fragmentation. I can run queries parallelly on three different servers. So that's what we understand. And but one more thing we have understood is it is still one application. Where is our headquarters? Headquarters is in the US. So suppose my CEO wants to know how many customers are there across the globe for me. Total number of customers. So my CEO is in US and he will be running a query in US saying what is the total number of customers for me. So then what we have to do is we have to go and access all the database servers to know the total number of customers across the globe, because it's just one application on the whole. For instance, I want to know how much profit I have achieved across the globe by selling products, or which product is selling maximum across the globe. Then I have to run a query which will be accessing every single database server, maybe perform joins across these databases and then get you one result at which site? The US site. So what we understand here is, though the database servers are independent, they have their own management systems, still they should have some kind of communication between them. They should be linked to each other so that when you run a query on one particular site, you're able to fetch the data across all the other sites. So when you're taking a look at this, I was talking to you about fragmentation, right? What is fragmentation? Taking one table and then splitting it, fragmenting it across different sites, across different servers. So how we have fragmented this particular table? Is it using rows or columns? Is it using rows or columns? Rows. See, all the UK customers here, all the US customers here, on the Indian customers here. So it is purely done using rows. So when you do a fragmentation like that, it's called as horizontal fragmentation. You call it as horizontal fragmentation. It's very much like horizontal partitioning and vertical partitioning. Okay. So that's what I have mentioned, the fragment 2, fragment 3 and fragment 1. We'll now take a look at the next thing, that is fragmentation. What is a fragmentation? System partitions a relation into several fragments and stores each fragment at a different site. So when you're talking about a distributed database, it's about having it at different geographical locations. Okay. Types of fragmentation: horizontal and vertical fragmentation. So what is horizontal fragmentation? Each row from the main relation is assigned to one or more fragments. So when you join all these three fragments, you should get that main relation, the customer relation. That's what is the meaning. What is an horizontal fragmentation? I have given some diagram here. So you split it using rows. Say all the Indian customers one side, all the UK customers on one side. Okay. Vertical fragmentation. It's like you will split it as columns, not as rows. So maybe I'll take these three columns, move it to one side. So ID, name and phone in one side, ID and country in another side. Just giving an example. Maybe this may not be a very good vertical fragment, but so one thing that is very important is when I do a join of these two things, I should be able to get my original relation. Okay. So you understood what is horizontal fragmentation and vertical fragmentation. Any doubts here? Another very, very important concept is replication. What do you mean by fragmentation? You take one table, break it into several pieces and store it in several sites. That is fragmentation. What is replication? You create a copy of one table in multiple sites. It's redundancy of your data in multiple sites. So let's go and see an example. We'll understand this with an example. Let's take two sites here. One is the US site and another one is the Indian site. So we have two locations and data stored in the US site is given here. That is the US site data. Data stored in the Indian site is also given here. These two databases have a link with each other because they are a distributed database. They should communicate with each other. And now what do you mean by replication is, I'll take the US data and then make a copy of that in the Indian location. Just copy this data and have a copy here. So what happens is the entire data gets copied and stored in another location. You call that replication. What is replication? You are just creating a duplicate copy of a database in another location in another part of the globe. So again, you talk about the Indian data. What I'll do is I'll create a replica of this server, database server somewhere else. So the copy of all this data is stored here. So you have created two replicas in multiple locations. See, the number of replications is not restricted. Again, it is something that is based on the product you are using. If you are going to use MongoDB, the number of replicas you can create can be huge. It depends on the product, how many replicas you can have. You can go up till 10 replicas for one database. So it's not limited to just one copy here. See, I can store a copy of this US data in 10 other locations across the globe. So that is replication. And what is the advantages of replication? What do you think? Why should we even do this? Why should we even have a copy of data like this?
Faster access of data.
Faster access of data locally. You know, I'm putting the US data in India. That is a very important thing. You know, if say your US server goes down, it's all physical machines, right? You have a database server and your hard disk may crash. So in that case, when your server goes down because of some network issue or anything, this one goes down. Immediately when a US customer wants to access something, see, this server is failed, so it will automatically route it to the available nearby replica. So say if India is the only nearby replica available, then that query will be answered using this particular data set. So it's like your systems are available 24/7. There is no downtime for your systems based on the number of replications you have. So that's how they have a business continuity plan. Even when one server goes down, automatically the servers in the other locations will be taking up, and you will not even know that this server is down. As a user, you will not even know that your server is down. You are contacting the next server available. So that is the concept of replication. It is very useful because it gives you 24/7 access, achieve parallelism on read operations. Another very good thing, say suppose you have two replicas, year one and year one, so, and you are only reading data. And if this server is really loaded, you can also read parallelly data from the other replicas. So you can do a multiple parallel read on the different replicas available. So you can achieve parallelism also using replicas. What are the disadvantages of replication? When I update my US site, all the 10 replicas across the globe should be synchronized, should be updated. That is a costly operation actually. And this is the only thing, increased overhead in propagating changes to all replicas across all sites. So how can I show a demo of replication in Oracle? That's very difficult. When you go in for distributed databases, you need independent database servers in different locations. With my one single laptop, it's not possible to show you the demo. But when you talk about replication, they will use very advanced tools. For instance, Oracle has the replication manager. A replication manager, it is available as part of Oracle Enterprise Manager. So if you go and download Oracle Enterprise Manager, you'll get the replication manager. So it's a graphical user interface. You can go and configure how many replications you want for a particular database. So it will create the replications for you. If you insert data into one table, automatically replications will be created in other sites in other tables. So they have some advanced tools, and the requirements are very huge. To run such tools, we need minimum 12 GB of RAM and 80 GB of hard disk. So I didn't go and explore such things with my laptop, which is just having 6 or 8 GB of RAM space. Mostly for replication, the kind of architecture that is followed is master slave architecture. Let me go and erase all these things. See, I can show you how replication works with MongoDB, because for MongoDB I was able to configure uh, main primary site, many replicas, and then I was able to do that. But since MongoDB we are not steady, I'm not showing you that demo here. So what MongoDB does is it has a master site, and then you have many slaves that are, these are the replicas. So you have slave 1, slave 2, and slave 3. All these things are nothing but database servers. So you can think them to be of database servers. And what do you mean by a master slave architecture? I can very well only write to the master. So if I am writing to the US server, that is called the master, whereas the replicas are called the slaves. When I write data to the master, immediately the data will be copied to the slaves. So you can, so these are replicas. One thing in the master slave architecture is you cannot write data directly to the replicas. You can write data only to the master. Whereas read from the slaves is allowed. You can also read data from the slaves and the master. To read data from the slaves, you should tweak your slave such that it allows you to read data from the slaves. So when they are maintaining replication, they are also using this master slave architecture for maintaining replication. I've gone through this kind of an architecture with the MongoDB. Okay. Again, we'll talk about distributed databases. There are two different kinds. One is homogeneous, another one is heterogeneous. What do you mean by homogeneous? All these sites have identical database management system software. Whereas with heterogeneous, different sites may use different database management system software. This is where the challenges become more with respect to distributed databases. So let me talk about this homogeneous site. Homogeneous distributed databases. What it means is every site, say it runs Oracle 11G, it will also run Oracle 11G, it will also run Oracle 11G. And every site uses a Windows 10 operating system. So it's all homogeneous across the globe. So that becomes a homogeneous distributed database management system. And it's very easy to work with multiple sites running the same database management software. With respect to heterogeneous, what happens is, say if I run Oracle 11G here, I may be using MySQL in one location. I may use SQL Server in another location. And also the operating system, one location it can be Linux, another place Windows, another place mainframe, ZOS operating system. So you are going to have different OS and different database management system software itself in many locations. So that becomes very difficult. Then how you establish a link between the databases, how you share data, that becomes very complex in this kind of a scenario. Are you all clear with what is distributed database? So now the question is, I am accessing data from the US server. Somewhere I need data from the UK server too. So I write, see my site is US site, and I am typing a query using my location, but I am asking for data from the UK server. So these two are two independent database management systems running on different machines. So will I be able to access data in the remote table from a local site? So that is the query. So for that, what we are going to use in Oracle is we are going to use database links. Database links in Oracle are used for accessing data from remote tables. So I have a database running here, and I have a database running in some other place. From here, I can access that database, the table inside that database. I can query that. So the concept that is used for that is database links. What are database links? A database link is a pointer that defines a one-way communication path from an Oracle database. Again, it's very specific to Oracle database server to another database server. So if I want to access, say, I have a database running here, another database running in Chennai. I want to access the data in Chennai from here. That's a remote database, right? So how can I access it? This I can use a database link, and what the database link allows me to do is from an Oracle database server, I can access another Oracle database server or a MySQL server or a SQL server database. So you can access any kinds of data, any kinds of database servers from here. That's what this means. An Oracle database server to any other database server. A database link connection allows local users to access data on remote databases. So what is a DB link? So I have given, this is a DB link. This arrow mark is a DB link. So from this site, if I run a query, say select count star on all the customers from UK, where customer country is equal to UK, something like that. I'm just focused on UK from US. So in that case, I should be from here able to access this remote database, find the answer, and then I should be able to give it to the user in site 1. So this, for this, we are going to use a database link. And you see here from Oracle 11G, I can very well query MySQL, a table inside MySQL database. From Oracle 11G, I can query something in MySQL. So when I create a DB link, it is one way. If I create a database link in Oracle 11G, it is one way I can do a query like this. So if I create a database link from MySQL to Oracle 11G, then I can be able to query whatever that is there in 11G. So now let us create a database link between two different database versions of Oracle. So let's create a database link between two different database versions. What I have done here is I have taken 11G, that is one of the main databases. It's the enterprise edition running in my laptop, and I have taken Express edition, that the smaller version of 11G. I have installed both these things in my system. So this, it's like two different servers running on my system, right? And they are two different servers. So I had installed these two databases, right? Then for 11G, the username is Satish. So we have a user Satish. In Express edition, I have a user by name Ram. So Satish creates this table employee, and Ram creates this table employee. So Ram is having access to this table employee. He is creating it on this Express edition. So what now Satish wants is, he wants to access the data in the employee table created by Ram using a different database server. So I have to contact a different database server, a different version, and get the data in the table created by RAM. When this database server runs on a remote machine, it becomes a remote database. That's it. So I have already installed all these things. Let me show you. So this is my XE edition, Express edition running, and you can very well see that, right? How can you see that? So select star from $V version. I think this should give you which version it is. This is database 11G Express edition. I have given that in red, and I also have my SQL Server 11G Enterprise edition running here. So you can see the version. So that is select star from $V version. So that is my Enterprise edition. That is my XE, and I'm going to connect here as Satish. So in my Enterprise edition, who is the user? Is the user Satish, whereas in my Express edition, the user is Ram, right? So I'm going to connect user as Ram. Ram has already created the table. So we'll go and see what table Ram has created. Select star from employee. So here, on purpose, I have given from Express. So to know that this data is on the Express edition on a different database server. So you see here, name is also XE2. So this is exactly on the Express edition on a different server. Now, can Satish from 11G access RAM's table? Can I do that? See, he has his own table, right? Select star from employee. He will not get whatever data that ROM is having. Is he getting anything like XE or anything? No, because this data is on a different server altogether. So how to create a link between these two database servers? For that, we have to write an Oracle query on 11G. So from 11G, we'll create a link to Express Edition. The query for that is, I will show you. This is how you have to create a query. Create database link keyword. DB link is the name of that link you are creating, the connection, and connect to which user I am connecting to RAM identified by his password. Because it's server, you have to give the username and password RAM using. So this is where we are mentioning where we are connecting to. So the protocol is TCP. The host. Here you have to give the IP address of your host. If it's running, where it's running, you have to contact the host. Here I am giving it as 12338 SESE, which is nothing but the host name of my own local machine. That's the computer name for my machine. And when you talk about Oracle databases, the port number they'll be using for listening to any request is 1521. So you have to connect it using 1521. And the server name for my Express databases, server ID is XE. So I have to give all these details. If I'm going to connect to a MySQL database, the server ID will be MySQL LD, the port will be 3306, and then I have to give where in which IP that particular server is running. So thereby you can connect to any database in this globe. So, but you should have the access. For instance, how you access it? RAM identified by RAM, which user and which schema you're going to access. So this is how you create a database link. And let me create a database link from my 11G to this particular machine XE. So where will you get all this data from? For that, you have to actually go and access two different files. Actually, if you go and look at your database installation, if you go to this particular directory, you will be able to get one file called tnsnames.ora file. So in this file, you will get what is the port number that your database is listening, what is the server ID for your database, all these things. So I have opened up that file too. Let me show you where that file is. Did I open it up? Yeah. So when I go to this is my 11G Enterprise Edition. When I open this file after going to that path, I'll be able to open up a file, and in this file, it very clearly says me all the details for Express Edition. The host is 12338 SESE, the port is 1521, and then the service name is XE. So I have to use these details for connecting in my DB link. So you want to connect to any database server, you have to go and access the tnsnames.ora file, and then you'll be able to get the data here. What is the server name, and what is the protocol, what is the host name, things like that. So using this, I am creating this file. So using this, I'm going to create a link by name dblink2. So let me just copy this and then go to my SQL, that is Enterprise Edition, paste this. So now you see here, a DB link is getting created between Enterprise 11G and XE. So once when this DB link is created, what I can do, I can go and access the table that RAM has created. So how can I access this? I can go and do a select star from, I'll give the table name employee at, and then I'll mention the DB link. Use this link and get the data. So that is DB link 2. So now if I perform this, you can see now I'm able to access the data from RAM table on a different server using 11G Enterprise Edition. So this data is actually where it is. It is in, you see this is in Express Edition 11G accessed by RAM. Now it is accessed from my Enterprise Edition directly using a database link. So like this, you can access a data from a MySQL database too by just using the correct phone number, correct port number, service name, and then the IP. You can establish a connection and access the data from a remote MySQL database or any other databases. So DB links, you can call them to be the backbone in a distributed database. Okay. So if I try to insert some record into that particular database from 11G, as a remote database is the employee database there. If I want to insert some record, say insert into employee at, I should always use the DB link name, DB link 2. Then I have to say, what I have to say here, I have to give the values, what values I'm going to insert. Say if I'm going to insert 11G record into Express Edition, so I'll give name to be 11G. Just giving some dummy values here. I'll just give 2, 2, 2, and then designation I will say from 11G. We are inserting this from 11G. And department number, we have some department number, say 111. Okay. See, one row is created, and can I really access this in XE and see whether this record is there? Can I really go to this server, check whether the newly inserted record is there? Select star from employee. You're not able to see that record, right? The record I've inserted is not visible here. That is because of one particular transaction processing concept. What you have to do is you have to commit your changes. When you commit your changes, you go there and take a look at select star from employee. Now your record 11G from 11G is updated. So there comes the concepts of transaction processing here. So that's why we ask you to commit your changes so that it is available to others. I mean, you can work on a remote table. That is the concept between DB links. Okay, so there are other things that we have to concentrate on. Let's go and see. This is what I have shown you. I have used 2 different database servers. One is 11G Enterprise Edition, 11G Express Edition. User is Satish, user is Ram. So Ram wants an employee table on the Express Edition. The objective is Satish should access Ram's employee table using a database link. That is our objective. And we have achieved that by creating a database link. The very important things that we have to give is, I am giving the host name as my own computer name because both these database servers running on my same system, and port is 1521. I told you how to know the port number for a database server, and the service ID is XE. Again, from the which file this I have received, tns names.ora file. After creating the link, you can also view the number of database links you have created by using this particular table, user underscore db underscore links. So how many database links you have created, you can go with that particular table. Say, if I want to know this, describe user underscore db underscore links. So you have the db link, username, password, host created. So let me do this, select star, select db link, that is the link I have created from user underscore db underscore links. So you see here, I have created 3 database links, db link 30, 35, 21, 30. So it gives me the names of all my database links. So you can also go and drop a database link. How can you go and drop a database link? Drop database link and then you give db link 2. Just give the db link name, it will drop the connection between these 2 databases. Okay. So we'll take a look at, now the data is distributed. One table, say you talk about one table in site 1, another table in site 2. I want to perform a join between these 2 tables. So it is a distributed database. So you have one table in site 1, another table in site 2. I want to join these 2 tables. What kind of algorithms you can think of, and what kind of approaches or strategies you can think of? We'll take a very simple join, and we'll talk about semi-join. These 2 algorithms we'll talk about. Let me go and show you what is the strategy here. Say you consider 3 sites you have. Let's talk about 3 different sites. This is one site. Site 1, you can think that of the US site. Site 2 is UK site, and site 3 is That is the Indian side. And you have two tables, three tables. One is R1, another table is R2, another table is R3. The condition is I want to make a join of R1, R2, R3 and get the output. Who is raising the query? Say a user who is in US accessing this database or accessing your application, he is raising this particular query. I need a join of relation R1, R2 and R3 from which site? Site S1. So what are the strategies you can think of? The tables are now in different sites. You can think of a nested loop join and a hash join that comes later on. But how will you even join these three tables? One simple plain strategy is it's all connected on the network, right? It's all on the network. Say they have a DB links between them. So what you can do is you can ship the entire R2 and R3 to site 1. You make a shipment of all these data, you just send it through the network so that you have the data locally in site 1, then you perform a join. That is one simple join strategy. So that join can be a nested loop join, hash join, sort merge join. In the local site, anything can happen. But what is the first thing? You ship everything out there. The only problem here is you have to pay some shipment cost. Shipment cost in the sense you have to ship a large table, all the tables across the network to a local site. Say I have 2 million records here, 2 million records here. I have to ship 4 million records to that site S1. So that is one disadvantage of this kind of an approach. So can we go and try a simple join between our two versions of the database? We consider XE to be the remote database. So can we go and try that? Say I have a table created here. Select star from department, I guess. Employee is here, right? So we have this employee table here in site. Say this is R2. I have my another version of SQL Plus running here. So I have this department table here. Select star from department. So I want to have a join between department in this server with employee in that server. So how can I go and have that join? I have created this database link, so I can go and have this join. So I can go and do a select star from. Say I want to have only the employee name and department name printed. So I'll have name, comma, d name from employee table where it is at db link 2. So I will give this db link to say this table is in that particular link server and then department. Will I get the output? I am getting a Cartesian join here because I didn't give the condition, right? So what is the condition? What is the condition here? This is D number and where employee dot department number is equal to department dot department number. So you see here how good this looks now. You have a join between data here and data here in two different machines, and it has achieved it. How it has achieved it? It uses an internal execution plan for that. So let's go and explain plan for this. How will you go and explain plan? Explain plan for. Okay, let me just type this. Explain plan for. We'll explain plan for this query. It is explain plan for, and then we'll give the condition, right? So plan is explained. How will you use this plan? Select star from that is table, and then you go with the dbms underscore explan dot display. Yeah, that's the plan, and the plan seems very interesting. You see, it says remote. What it means is the employee table is on a remote database, and this is accessing the entire employee table. So the entire employee table got shipped from the XE server to the 11G enterprise server. That's the meaning there. And then it is performing a merge sort join locally. What do you mean by a merge sort join? What is the first step in a merge sort merge join? First you have to sort the relation. So which is not sorted, the employee, it fetches it from the remote database, does a sort join, Then it scans the department locally, department table in 11G. Then it does a merge join with the employee table. So when you take a look at this, it very well says remote in the sense it's accessing a remote database from another server. Other than that, it is not really telling me much details about what it's doing for the shipment. Maybe if I try and get more data on how that thing happens, I'll tell you. But is this clear how join happens between? That's a simple join. From the execution plan, did you understand something? What we understand is employee gets shipped to the another site. So that's a kind of a simple join we are seeing here. So that is the first step, first strategy, or they have given another strategy here. Say if you take a look at the three sites again, the another strategy that they are telling us is, let me go and erase everything and then come back again. So let's again take these three sites. This is site S1, this is site S2, and this is site S3. So you have R1 here, R2 here, R3 here. The first strategy was you take all the other tables, ship it to site 1. The next strategy is we'll not do that. What we'll do is we'll go here. Ship a copy of R1 to S2. So we are going to do ship this R1 to site 2. So you are going to get R1 here. And then you do a join of R1 and R3. So you're just shipping one table out there. After you do a join, you'll get temp1. That is the result of join of R3 and R1. So this is actually R2, right? In site 2 we'll have R2, in site 3 we'll have R3. We'll make this small change. So you'll have R2 joined with R1 and you get temp1. Now what you have to do is you have to ship temp1 to S3. Again you're shipping just one table out here. So it is temp1. You're going to join that with R3. So this will be your final result, right? You'll get the result here. This result should be shipped back to S1. So why we are focused on site S1? Because that's where the query originated. So you have to send the results to site S1. So this is another strategy. But what are the disadvantages of this strategy? When I join two tables and ship, it will become more bigger table, right? Again, when I join three tables and ship, that will be more a bigger problem. So you can generate any such strategies. See, there is no such strategy like I'll always do this, I'll always perform this. It depends on the size, the shipment cost and things like that. If the size is very less, I can very well ship all the tables to one side. If the size is very large for two tables and very small for one table, I have to take a different strategy. So that kind of strategy is taken internally by the optimizer, which is working on the query. Okay. We'll talk about another join strategy, the semi-join strategy. Here what they are saying is when you're talking about joining two tables, it's not that always all the records here will join with all the records here. So why should we even ship an entire table to that side? So they propose a different strategy. What is that they're saying is, you take the schemas first, find an intersection of that in site R1, and then you send that result to site S2, you find a join, then you send it back to site S1, you find a join to get the result. That's what is given in your textbooks. I know it may be a little confusing for us, so I went in for a example. So consider this to be relation R1 at site S1. This is at site S1. This is relation R2 at site S2. So what is our objective? Here we have the employee ID, name and department number. You have department number and department name. So our objective is to print employee name and department name for all employees. So what should be the output? Sam, to which department is working for? Scope. Ram, to which department is working for? SBST. So I have to perform a join between these two tables. These two tables are two different servers. Now, what shall be the approach? See, if I'm going to ship this entire department table here to the employee side, what is the problem? I need only two records for joining, but unnecessarily I'm shifting all the other records that are not going to be part of my join. So unnecessary waste of this. So that will be a costly operation. So what they suggest is, in this scenario, what you can do is, first you consider the schemas. Say you call this schema to be R1, you call this schema to be R2, schemas alone. And you do an intersection of these schemas, R1 intersection R2. What is the intersection of schemas alone here? Department number is the common item available in both these schemas. So what you get? Department number. And you find all the departments corresponding to that department number in R1. So what is that you're going to get? For this particular intersection, you're going to get at R1 only these values. So intersection gave me D number. It is on R1, right? This is R1. So what values I'm going to get? 1, 1, 1 and 2, 2, 2. So what I'm going to do now is, I'm going to go to step 2. That is, you have to shift this to site 2. So here we are having only site S1 and site S2. Say this is in site S1, this is in site S2, right? So I have found this in site S1, I'm shipping it to site S2. So what I'm going to ship to site S2, you call that to be temp 1. So at site, this is actually S2, I'm sorry. So at site S2, what is happening? What we have to compute is temp 1 and R2. What is R2 here? Department table. What is temp 1? Temp 1 is what we have just now arrived at. This is temp 1. So what is temp 1? Join R2. So this is temp 1, this is R2. What is the join of these two things? So this 1, 1, 1 as a join, so 2, 2, 2 as a join. So the join will be only 1, 1, 1 and 2, 2, 2. So this is happening at site S2 where your department table is. And now what we are going to do is, we are going to go to step 3. That is, at site 1, what we are going to do is temp 2 join R1. So you are going to ship whatever you arrived at site 2. This is site 2, right? So whatever you arrived at site 2, you ship to now site 1. And then you are going to have a join between the employee table and the department table. So what this join will give us finally? Name department. So what we have achieved here is, we have avoided the transfer of unnecessary records that do not take part in a join between two sites. So this is another strategy. You call that to be semi-join.